All right, so hopefully you've tried to integrate something like this. I'm going to go ahead and do it here. This time I'll do it. So what happens? I'm integrating with respect to y. So this is a constant, so I get x times y plus 5/2 times y squared, and I'm going to evaluate from y equals 0 to y equals x. So I plug in my upper limit first, so I get x times x plus 5/2 x squared minus the quantity x times 0 plus 5/2 times 0 squared. And so that just gives me x squared plus 5/2 squared, so I get 7/2 x squared. All right, what if I gave you an integral that looked like this? I have the integral from 1 to 2 of the integral from 0 to 3y of 4y squared x dx dy. Well, this is an example of an iterated integral. So it's called iterated because we're integrating again. And I want to think of this by just doing the inside integral first, and then I'll do the integral with respect to y. So inside here, we've already done this integral, right? We have the integral from 1 to 2. I'm just going to leave the outside alone. And when we did this one, we got 18y to the 4th, and then I have the dy. And now I just want to integrate this with respect to y, and I don't have any x's left here. So this is an integral that you were doing in Calc 1. So I'm going to have 18y to the 5th divided by 5, evaluated from 1 to 2. And so that gives me 18 times 2 to the 5th divided by 5, minus 18 times 1 to the 5th divided by 5. And once you work all that out, you get 111.6. Okay, so for this example, the region of integration is given by the bounds on my integrals. So for y, the bounds were 0 is less than or 0 is less than or equal to y. Nope, I did it backwards. Sorry. Less than or equal to x. Let's do that first. Less than or equal to 3y. So I looked here at dx and the bounds on x. And now let's look at y. Here's y. And the bounds on y. Whoops. Y went from 1 to 2. Now I could sketch a picture of this. So I'm going to draw the xy axis. And I want to sketch, so if I have x equals 3y, that's the line y equals 1/3 x. So I want to sketch that line. So let me mark my axes real quick. So when x is 3, I get 1, and when x is 6, I get 2. And when x is 0, I get 0. So here's my line. And my bounds on, keep going. My bounds on y were from 1 to 2. So 1 to 2. And so my region of integration is the region bounded by all of these bounds right here. So this is R, and it satisfies these two inequalities, right? The points in that shaded region have x values between 0 and 3y, and y values between 1 and 2. Okay, so in general, iterated integrals are of the form integral from a to b of the integral from g1 of x to g2 of x of some function f of x, y. So my inside integral is with respect to y, and then my outside integral is with respect to x. Or we could go from c to d and then integrate from h1 of y to h2 of y, f of x, y. Here I'm going to switch the order, dx, dy. So my inside integral is with respect to x, and my outside integral is with respect to y. All right, I'd like you to try an iterated integral. How about the integral from 0 to 2 of the integral from 0 to 8 of x plus 4y dy dx. You should go ahead and pause the video and try an example on WebAssign that looks very similar to this. Your numbers might look a little bit different. So go ahead and pause the video and do that. I'm actually going to stop the video, and when you come back, we'll look at another example.